All right, thank you. So yeah, today we're going to be talking about machine learning and how you can integrate, Power BI and the Azure Machine Learning Studio platform with SQL Server and R. So just a little bit about me, just to cover the agenda. So first I'll introduce myself, just cover some, basic terms and definitions so that we're all on the same page. Talk a little bit about why this technology is relevant and give a quick overview of the Azure Machine Learning Studio platform, also Power BI, and then I'm going to dive into like a demo where we kind of pick apart something that was built and end it off with a discussion around some use cases and open it up to questions and answers. So a little bit about me. My name is Anthony Bulk. I work for Sierra Systems. They're a top tier IT services and management consulting firm. I've been working in the BI industry for over 15 years now, or 12 years and 15 in IT. I've worked in both public and private sector, and I actually am an organizer of the Power BI user group here in Victoria, BC. And actually, a couple weeks ago, we had a SQL Saturday event here, so I had the chance to speak at that event too. It was really a great experience. I'm a partner seller with Microsoft. I presented at Build last year. I also presented at the Power BI World Tour. And then I also was an architect for an award-winning solution that won an Impact Award last year, as well as 2 CDN awards. And I'm also part of a bunch of different advisory groups with Microsoft. So just to cover some terms and definitions. So artificial intelligence, also sometimes referred to as augmented intelligence or aided intelligence. It's a broad definition and it includes subsets of machine learning and deep learning. Machine learning, that's where it's a little bit more focused, and you're typically kind of looking at different algorithms to predict or classify data, and it's kind of where you are doing more feature engineering, and you have a specific set of algorithms that you're kind of trying to use on that data. And then the hot thing, of course, is deep learning. So that's where you think about self-driving cars. You think about all of the kind of more magical things happening in AI these days, where you have multiple levels of a neural network, and that's more of a niche within the machine learning realm. And then the last one, cognitive computing, that's still an evolving definition, but essentially anything that kind of mimics the human brain, such as vision, functions of the human brain, such as vision, speech, recognition, even kind of recommendations. So those are some kind of high-level terms to set the groundwork. I just want to talk a little bit about why this technology is relevant. The reality is that it does exist today. It's cheap, fast, and reliable. And organizations that leverage this technology, they're able to get a competitive advantage or maintain their competitive advantages. And the reality is, if you don't kind of start to figure out how to use this, you will be left behind. We see this, of course, because every head of industry is talking about how much this is going to have an impact on everybody in every aspect across the board. So it's really good for us as data professionals to learn about this technology and to learn how to apply it. And that's why I'm kind of hoping this webinar will be so valuable for people today, because I really want to empower people and show them that this is it's not as scary as it looks, and there's ways to quickly leverage it and show it to other people. So before, it was very difficult to get into advanced analytics. So quite often, most organizations, they'd start off with descriptive, maybe get up to diagnostic analytics, but then going into the foresight area, there was a barrier to entry because you had to have the right skills, and you had to have very powerful hardware and technology to get to that kind of gold mine of predictive or prescriptive analytics. So quite often organizations would stop once they got to the middle line of insight there. But what is happening today is that because of technology advances, it's becoming easier and easier for organizations to leverage these capabilities. There's a big push to democratize AI, and you see that, right? Like all of the major vendors, whether they're Microsoft or Google or IBM, they're all offering platforms and frameworks and tools essentially for developers or data professionals to use and to start enabling these capabilities for the average organization. And so I do believe this trend will continue. And so it's good for all of us to be prepared for, the requirement that users are going to have and say, you know what, I need the ability to, right away see what the customer's behavior is going to be in the future, for example, right? Or, that requirement to predict what's going to happen down the road will be more of a requirement as time goes on. And so within the BI space, or even kind of just in decision support in general, right? There used to be silos where you had operational reporting, which is really like on the ground, right? How you're doing today. Business intelligence was typically looking at historical data and trying to understand, what happened and maybe why did it happen. And then artificial intelligence was, your data scientists or your statisticians that were looking forward and trying to kind of predict what could happen, but they were in separate silos. And as time went on, these technologies, they start to fill in the gaps, right? So, you're seeing now ways to pump in streaming analytics directly into your BI system. Like with Microsoft, they have the Azure analysis or streaming analytics service that can pump data right into Power BI into your dashboard, so you can start to see real-time monitoring and combine that with historical analysis. And then we're also starting to see that on the other end too, where different tools are introducing these abilities to get like quick insights, right? So for example, with Power BI, again, you have the ability to drop some data into the cloud, and it can automatically do some analysis of that and suggest things that might be of interest or value to you to help you make decisions. So we're starting to see that kind of happening more and more, and it will continue, and it'll be essentially at the point where there's no longer a gap between operational reporting and business intelligence and artificial intelligence. You'll have like essentially a single dashboard that will give you all of the information that you need at your fingertips in a single pane of glass. Because again, if you're a decision maker, you don't want to have your train of thought disrupted. You want to have one spot that gives you all of the information you need with, regard. So for example, you might have one section of your dashboard that tells you, what the customer bought today, right? It's really kind of operational. And then you might have another section of that dashboard that tells you, okay, well, what have their buying trends been like over the past, several years? And then you might have another section of that dashboard that gives you predictions on what they're going to buy or how their buying behavior might change over time. So you're going to see everything kind of coming together, and there being less and less of a lines of division between the different forms of decision making and where that data can come from. Because again, artificial intelligence is just a new form of data, and business intelligence again is data that goes further back in the past, and operational reporting is really just looking at data that's relevant today. So in terms of what we're going to be covering today, so we'll be looking at the Azure Machine Learning Studio platform, and also Power BI. And then we're also going to be looking at a little bit of R code and SQL Server. But those are the two kind of major things that I'm going to be talking about today. So just so everybody's aware, the Azure Machine Learning Platform, it's a cloud predictive analytics service. I believe it's a platform as a service or even software as a service. And then there's also the Studio tool, which is a really nice tool to do kind of drag, drop, and configure of building experiments in the cloud. So if you've done any kind of, SSIS development, this platform will seem very familiar and intuitive to you. And so it's a great way if you're kind of even just starting out with, I'd like to learn more about machine learning or artificial intelligence. I highly recommend that you play around with the Azure Machine Learning Studio platform because it allows you to quickly build experiments, but then also evaluate them. And as you start to use the platform, you'll understand the different terms and what you need to measure to see if the model is successful or not. And Power BI, again, that's I think most people have Power BI has been around now for a little while, and it's really gained a huge amount of popularity. But it's really a great way to visualize and build very sexy reports and dashboards that everybody gets excited about. And it's actually composed of several different components. So there is the desktop tool, which you can download for free. You can start authoring and building reports with that. You can connect to many different data sources. And then if you want to share that, you can either publish it to the cloud. There is an on-prem version available now. So if you don't want to publish anything to the cloud, you can keep it on-premise. Or if you do want to publish it to the cloud, but you want to keep the data on-prem, you can create a hybrid scenario where you're using the Power BI gateway. In that situation, the data stays on-prem, the results go up to the cloud when the users are interacting with the report, but they do not persist in the cloud. And then of course, these things are available on any device. So there is an app for your, Android, iOS, and Microsoft phones, and then also you can access it with, any kind of web browser if you're using the cloud service. And you can also do it if you're using the on-prem version too. So in terms of what I'm going to be demoing today, so what I'm going to show you is how you can use the Power BI desktop to go and pull data out of SQL Server, which is just running on-prem on my laptop here. And then I'm going to send that up to the Azure Machine Learning predictive experiment that I have created. And it'll send me back the scored results. And one thing I really want to stress today, everything that I'm going to show you, you can do for free. So I hope that lots of you are interested in trying this out, and by all means, again, I can't stress this enough. It's all free. It's all easily accessible. So please feel free to try and learn and play. So now I'm going to jump into the demo. So I'll just start off here with this Power BI report. And so what this Power BI report is showing is, would you survive the Titanic? And again, the reason why I'm showing this data set is because this, if you're, if you ever played around with the Azure Machine Learning Studio platform, one of the popular tutorials is, creating an experiment on, passengers of the Titanic and predicting whether or not they would survive. So, the reason why I picked this data set was because it's a very popular, well-known data set within the Azure Machine Learning Studio platform. And this data set does have a couple of different widgets on it. So I have a slicer here on the left that lets you specify different age ranges. I have another slicer here that lets you specify
Anthony, where we
or
can download this data set?
so this data set is actually available with the Titanic tutorial in the Azure Machine Learning. So when you, and I'll get to that in a minute, but when you go and download or start up the template, you'll automatically get the data set. you can also get it from Kaggle. So Kaggle is also a great platform for people that are kind of getting into data science and want to try and download different data sets for experimentation. So there's two spots where you can get it. And then below the gender slicer, I just have a slicer here that lets you look at individuals to see whether or not they survived. I have a couple of cards here along the top. So new lets you know whether or not there's any new passengers that we don't have a prediction for yet. This shows you the total number of passengers, their average age. I have a little chart here showing you whether or not they would survive or perish, and then as well as a couple of gauges. I did put the map here. It's not the best visual to use, but I included it for the purposes of this demo because when I go and add some new passengers, you'll be able to see where they got on board. I'll be able to identify them really quickly. And then down below here, I have some details regarding each passenger, whether, their name, their gender, their cabin, and whether or not they survived or perished. So that is the Power BI dashboard. And I'll just quickly show you now the database. So inside SQL Server, I have just two tables. So I have the list of passengers. So these are people that are on the Titanic. And then I also have another table here that lets you know, basically it stores the scored predictions, what the results from the Azure machine learning platform. So I just have the passenger ID, the label, whether or not it's survive, which is a 1, or 0, which is perish, and then the probability, like how close each individual is either to the 1 or 0 side of the line. And I might just quickly jump into the demo for a minute. So imagine this scenario where we have invented a time machine and we want to predict whether or not certain individuals will survive or perish. So I'm going to insert a couple of new records into my Titanic passengers table here. I'm going to add Leonardo DiCaprio. I'm going to add myself. I'm going to add Kate Winslet and Hillary Clinton. So those are the 4 new passengers that somehow went back in time and snuck onto the ship. I'm also setting them to all get in BC because I'm in BC. So who knows? Maybe they invented the time machine here in Canada. We're doing some pretty advanced stuff. So I'm going to insert these new records. And you can see 4 new rows have been added. I'm going to go back to my Power BI report, and I'm just going to hit the refresh button here. And what it's doing, it's actually running an R script. So dataset 1 is an R script, and it's pulling data out of my list of passengers. So grabbing those 4 new records, it's sending it up to the cloud to get scored. And then the results are coming back into my R script and getting loaded into my my scored passengers table there. So you can see that the Power BI report updated, and I now have 4 new passengers. So I have a total of 895. And you can see on my map here that they all boarded in British Columbia. So I can select that. And I can see here, there's me, Hillary Clinton, Kate, and Leonardo DiCaprio. And we can see whether or not, we survived or perished. I'll just pop this out for a minute. So for me, the machine thinks I'm definitely dead, which is probably true because I'm a male and I'm 38 and I am in first class, but again, doesn't look so good for me. The next one, Hillary Clinton, she survives, and the machine is our predictive experiment is very confident that she will survive, which is probably true. And Kate Winslet, I think we all know that she survives, but the machine, if you haven't seen the movie, she does survive, but our algorithm isn't quite as confident with her. And then the last one, Leonardo DiCaprio, he does perish. So now I'm going to walk through how I did this. And the one thing I wanted to mention too is that this is put together, it really kind of came out of the fact that, you know, when you're producing these different predictive models or predictive experiments, business users, they don't get excited about, you know, the area under the curve or the R squared value or the confusion matrix, right? Those are all ways that a data scientist would be, you know, look at and go, oh, that looks like a great model. But until you can take that, you know, predictive data and integrate it with something that's real that an average business user can understand, they won't get excited about that. So this is a way to quickly, you know, produce something that is visually appealing, that, you know, average users can understand and see value in really quickly. And not only does it allow you to get kind of buy-in and get, you know, get traction and get excitement, but you can also do some further analysis within Power BI. So if I flip to the details page here, you can start to look at, you know, okay, well, we got 821 correct, we got 74 wrong, right? Which ones did we get wrong? Well, this one, this passenger here, it predicted that, you know, this person would survive, but they actually perished, right? So not only does it allow you to get excited, get the users excited about the possibilities, it also helps to explain, you know, what went wrong, and then you can make a decision about whether or not you should further refine the data. So maybe you do some more feature engineering, or maybe you do some more tuning of your model to get better results. But at least you can have like a you know, conversation that the average user can understand using real data about that. So now I'm just going to kind of walk backwards through what is going on here in this Power BI report. So the first thing I want to mention is there are several different data sets, and maybe I'll just flip to the relationship diagram here. So data set one, this is the R code. This actually does all of the orchestration. And the other ones here, this is just my original data. So that's what I use to compare and see, okay, are my predictions you know, right or wrong? The complete passenger list, this just is, you know, combines the scored results with the passengers in the two tables there. So inside SQL Server, I have a very simple view that just combines both this Titanic survival table with the Titanic passengers. I'll just show you what that looks like for a minute. So I basically just said, okay, give me everybody that's in the passenger list and join it to the Titanic survival list. And the reason why I did that is because I just wanted to have like a really simple denormalized data set to work with in Power BI. So that's what this complete passenger list is, those two tables combined together. And then my extra life rafts and my water temperature, that's actually for a third page where I can play around a little bit with what if scenarios. So, you know, what if we had more life rafts, right? How does the survival rate look? What if the water temperature was colder, right? How does the survival rates look? So those are kind of the different data sets. And I'll now show you what that actually looks like, the R code, because that's the real engine that, you know, drives everything. So my data set, all it does is return this number of new passengers, and it's based off of an R data source. So if I click on the gear here, you can see the R script. Now when you first look at this, you might be a little bit overwhelmed and go, wow, there's lots of lines of code in here. You know, how am I going to understand or use this? One thing I want to mention is that most of this code is generated by the Azure Machine Learning Studio platform. I would say probably 90% of the code is generated. And I'll just show you that for a minute. So inside the Azure Machine Learning Studio, I am using this experiment So there's two phases to creating an experiment. There is the training phase, and then there's a prediction phase. And so right now I'm showing you the end result, right? And what happens is when you're kind of done iterating through different experiments, refining which models you use, refining your data, then you flip it over and you deploy it as or create a predictive experiment off of that. And in the end, when you're done creating a predictive experiment, you will deploy it as a web service. And once it's a web service, that's when you can call it with R or C# or any kind of language, right? Because you're just calling an API. And so what I did was basically use R code to go and call the API to bring back the scored data. And I'm kind of flipping around here, but again, I'll walk back to this later on. So, once you're done experimenting, you have your predictive experiment, you create a web service. It's just a single click to do that. And this is what the web service looks like. And you can see here too that you also have the ability of interacting with this experiment, this web service inside Excel. So the nice thing is if you do it in Excel, you can obviously enter in new data. So if you don't want to just visualize it and you want to use just Excel, you can do that. But I wanted to show you how you can do it in R or in Power BI. So click on the request response API documentation. And this provides you information on what data this predictive API is expecting. So you can see here's a list of columns, and below it also shows you what the results will be. So I get the passenger ID back along with the scored labels and the scored probabilities. And the really cool thing is at the end, it gives you sample code. So as I mentioned before, when we were looking at the Power BI R script, most of the R code is generated. So you can see here, one of the tabs is R. So pretty much all of the code that that you see there in the R script, it's just a copy and paste, right? You just take what this already generated for you, the sample code, and then you tweak it. So I'm going to flip to the tweaks that I made to essentially set it up so that it could pull data out of my local SQL Server instance and then send that up to the service and then take the results back and load them back into SQL Server. So I'm not going to step through the code in this tool because this is really difficult to walk through. I don't recommend doing, unless you're like a hardcore R developer, I recommend that you use like RStudio or Visual Studio to do R code development. So I'm going to open up this R script in RStudio. I'll just walk you through the code a little bit. So I'll show you the sections that I modified. So the first bit here was I added a library called to RODBC. This is a package. This allows you to make an ODBC connection, and I'm creating an ODBC connection to my SQL Server database. But again, that ODBC connection could be to any database. It could be to Oracle, it could be to Microsoft Access, right? Any database that you can make an ODBC connection to, you can use. Here's where I go and establish the connection, again, just to my local instance. And this section here is where I go and pull passengers out of my list of Titanic passengers, the table that I showed you before. And I'm just grabbing passengers that are new. So I'm not going to grab passengers that have already been scored and that are stored in the Titanic survival table. So that's why I have this where not in clause to limit that list. Then I do a little check to see, okay, well, is there anybody new? Because there's no point in going and calling the web service if there's no data that I'm going to send to it, right? So this just does a little check to see, okay, were there any rows found in my list of passengers? And if there are, that's where I go and do a little bit of manipulation of the data. So this is a function that essentially takes those results out of the database and creates a list of lists that is comma separated and has quotation marks. I could have used like a for loop, but this is a better way of, more efficient way of creating that list of lists. And the reason why you can see that in the code here in the example. So down below here where it says values, list, and then quotes, this is the format that the code needs to be in when you go and send data up to the API to be scored. So that little function there, that's what it does. It just basically, makes sure that the data that's coming out of my database is formatted properly. Then most of this stuff is all generated by the service, so I didn't really touch any of this. The only part I changed was this create list here. And again, going back to what's generated by the platform, I'm basically replacing this section of code with the function. And the function just takes all of the data coming out of my database and puts it into a nice list of lists with quotes. All of this stuff is the same, except of course for the API key. It will tell you that you need to get that from the platform, which you can do, right at the top. I believe it's at the top.
Hey Anthony, quick question
Yes.
related to this. Eva is asking, can we have the password in the connection string and that is encrypted?
So I actually would recommend, because I'm running this on my laptop, I don't have a domain controller. So if I were doing this in a production environment, I wouldn't even use SQL Server authentication. I would just use Windows authentication, and then I would rely on the credentials of the user who's trying to run the Power BI report to dictate whether or not they have access to SQL Server. And again, it's
Oh,
just because, yeah, I don't have a domain controller running on here, and I wanted to make it easy to go and connect.
yeah. And Sarah is asking like how we can share the R code, or what are the models we can share? Like, can we save somewhere and then share the code, or what do you suggest?
For this demo, this code?
No, the in general, like in development, how we will share the code.
Okay, yeah, I'll get to that, because this code right now, it's inside Power BI, right? Which is not a very secure or robust kind of way of. It's kind of more of a quick and dirty way of doing this, right? And
Oh,
again,
okay.
the intent was to, the situation is you have a nice predictive model and you want to get business buy-in. How can you do that quickly? Well, a quick way to do that is to leverage R and leverage the ability to run R inside Power BI. But later on, and I'll get back to that in my slide deck, I would actually move the code out of Power BI and integrate that into SQL Server. So like SQL Server, 2016 and above, you can run R code inside of the database where it's secure, where it can be managed properly. And I'll get to that in a little bit.
Yeah. And last question related to this, like, can you share this R script code also? I mean, with the attendees.
Yeah, absolutely. I can share all of this stuff. And
Thank you.
actually, I blogged about this too. So if you look me up on LinkedIn, I have all of the details and all the steps that I'm talking about today. I wrote 2 articles about it, so you can follow those articles with code snippets too.
Sure. At the end of the session, if you can just show where it is, that will be good.
Sure, will do.
Okay.
So yeah, this little bit of code, of course, is modified because you have to put in your key. That's it for that. And then the only section that I also modified was down below here. So when you get the results back from the web service, you can use this from JSON-results, right? And this essentially creates a list of lists, which is like a kind of dynamic bucket within R to store the results. So, the results come back in a JSON format. Those results get stored in a list of lists. And then I navigate through that list of lists and get the values, which is what I'm doing here. I'm taking all the values and I'm, creating a vector with that. and then turning that into a data frame. And I'm also putting the names of the columns, which is also comes back from the service. And I'm making sure that my data frame is labeled with those names. And the reason why I do that is because the easiest way to get data from R into SQL Server is to put it into a data frame and then load that data frame into a table. So, this R code gets the results back from the Azure experiment and puts it into a data frame. And then I just do a little bit of manipulating of the data so that to make sure it's in the right data types, because it's a lot easier to load that data frame into a table if all of the factors are of the right data type. And then the last little bit here is I make a connection again to my local SQL Server database, and then I load that data frame into a table called Titanic Survival. So Titanic Final is my data frame that has the results that came back from the Azure Machine Learning service. And then my table is inside SQL Server, which I showed you here. It's this Titanic Survival with the passenger ID and the scored label and scored probability. And I load that in. And then at the very end, I just say, okay, this is how many new passengers were scored. So you can just basically say, okay, give me a count of the number of rows in that data set and return that. And that way that when I run the R script, Power BI has like a data set that I can use and visualize. So this data set one, number of new passengers, is actually showing you the number of passengers on that one card. So I'm going to click cancel here. Let's close that. So that R script in the end, after it goes and sends data up to the cloud, gets the results back and loads it into a table. It then returns one single value, which is the number of new passengers that snuck on board the Titanic. So the R code here, it's actually not doing any predictions or modeling. The R code is just doing orchestration, right? It's just basically pulling data out of SQL Server, sending it up to the web API and getting the results back, and then loading it into a table inside my database. And the nice thing is that R code is always executed first. There is no way in Power BI to specify the order in which queries get executed, but I've been playing around with this because I wanted to confirm, because actually I had someone recently ask me, oh, how did you set it up so that R goes first? Well, it just does, because it executes the fastest, I believe, compared to the other results. So the R code always gets executed first, and then the other queries get executed, and then it starts to show the data inside the Power BI report. And so if you want to try this yourself, as I mentioned, right, the platform is a great way to start learning about machine learning. So if you go to the platform, you can sign up for free. Anybody can do this. You can go and create a new blank experiment, and it gives you this nice friendly canvas, and it really tells you what you need to do to drag and create things. Essentially, you're picking different modules and you're configuring them, and then you're hooking up the modules to dictate the flow of data through those different modules. And then once you're kind of familiar with the platform and how to navigate it and use the different modules within it, I recommend jumping into the tutorial for building a classification model in Azure ML. This is the Titanic tutorial. So you can read about it here, to better understand it. There's a bunch of related information. And if you want to just dive in and try it, you can click Open in Studio, and that will open up essentially a blank experiment that looks just like this. So this is the tutorial that opens up when you click in Open in Studio. and you can step through the different code. You can see what it's doing. And this one, the really cool thing about this platform is that it allows you to rapidly iterate through different experiments and try different things. So, we are using a 2-class boosted decision tree, and we're comparing that to a 2-class decision forest. So you can just drag these things on, hook them up, click the evaluate, and compare them and see actually which algorithm is giving me the best results in terms of accuracy and precision and recall. And so you can see here that actually the decision forest gives me slightly better results than the decision tree. And so not only does it allow you to compare different types of models, but you can also do things like, do hyperparameter tuning really quickly and find the optimal parameters for whatever module you're using. Now, of course, not all modules support that. Not all algorithms support that, but for the ones that do, it's a great way in kind of isolating and finding the best fit for purpose. And so this is when you're in kind of the experimentation mode. And when you're ready to set up a web service, it's really just a single click, right? And you say, okay, convert this into a predictive web service. And then you might modify it a little bit, because when you're experimenting, you're using all of the data, right? You need to pass in all the different features that it needs to train with to make those predictions. Once you have the model, you don't need to pass it everything, you don't need to get all the same data back. You might only need the identifier and the scored results. So that's what you'll see in my other experiment, my predictive one. So I'll flip to that for a minute here and show you. So this is, I'm done my experimenting. I've now converted it into a predictive experiment. And I modified a couple of things because I only want to have the passenger ID and the score come out of it. I don't necessarily need all of that stuff to come out. So you modify what comes out of it. I did it here by selecting different columns to come out, and then it creates a web service, and then it's just a single click to deploy it as a web service. I'm not going to do that right now. And then you can start integrating that with any kind of technology, whether it's SSIS, SQL Server, or Power BI, which I'm showing you here today. So I might just flip back to the slide deck for a minute and recap what we just saw. So as I mentioned, it's going to walk through what happened here. So step one, we used some R code inside Power BI. Most of that R code was generated by the platform. I just made a couple of tweaks. I added the ability to, like an ODBC connection, to go and pull data out of SQL Server. I did a little bit of formatting of that data. And then I took those results, put them in a data frame, and loaded the data frame into a database. So step one, again, was to pull the data out using an ODBC connection. Step two, the R code then takes that data and passes it up to the predictive API to go and score, essentially. Those results are sent back to the R script as a JSON, and then we do a little bit of formatting of that those results to get it into like a data frame. Then I load that in step 4 into the database, so into a new table called Titanic Survival. And then the last step, Power BI goes and gets the new data from that those two new tables, and then you can visualize it on your report or dashboard. So again, as I mentioned, this is a way to quickly show the power of your predictive experiment and hopefully get business buy-in. Now, I don't recommend that you embed R code in Power BI and you start using managing all of your code that way. A better kind of thing to do is to move the R code into SQL Server. When you do that, you don't need the ODBC connection because you're going to be running it inside SQL Server. And you also need to use the execute external script command to basically run that R code. And then through parameters, you pass in the data into that R code, which will then do the orchestration. Now, the only drawback, of course, with this design, the nice thing is with having it in Power BI is, you can literally refresh the data in Power BI and see new results. If I were to refresh this, it would only give me the latest results from those tables. If I wanted to still have the capability of getting new data scored, what I would have to do is create like a database procedure, and Power BI would have to go and execute that database procedure, which would then go and execute the R code and get new results and pass that up to Power BI. So this is a step better to make your R code a little bit more, or the whole solution a little bit more robust and secure. There's lots of other variations, of course, with this too. But I would say this is the next kind of natural evolution, because you could also say too that if you have, for example, a data warehouse, right? You might want to then use SSIS and then maybe use the C# code example and have your data get scored through a script in SSIS while it's loading the data warehouse, right? But there's lots of different options essentially to integrate those experiments and to collect those prediction results into whatever platform or mechanism that you need. So I just kind of showed you one example. It's kind of maybe fun or interesting to know who's going to survive the Titanic. And again, the reason why I did that is because there is a great tutorial. You can do it yourself, but there's lots of different options out there. And once you start to play around with this technology and you start to think about the different possibilities, you start to realize that there's a plethora of use cases that this can be applied to. For example, predictive maintenance, right? Knowing when something's going to fail before it happens. Resource planning, right? Knowing where to staff people at the right time. Employee retention, supply chain management, right? The list goes on and on and on. And we're also finding too that, the platform, it is a great way to quickly go through different experiments, find the best fit for purpose. You also do have the option too of kind of leveraging what you've learned in the platform and then making a decision whether or not you actually want to continue to use the cloud, or now that I know a boosted decision tree is going to give me the best results, I'm actually going to write some code in Python or R and I'm just going to use it on-prem. Because more than half the battle is finding out what you need to do to the data and finding out which model to pick and which parameters should be applied to that model. So if you can use the platform to quickly iterate and find the best fit, then you can leverage that and make a decision and say, you know what, it's going to be too expensive to use the cloud because we got to run it every day. Let's write some code either in R or in Python, and we're going to use the appropriate library that has the right function or model that we need, because we now know it's this type of model and these type of parameters. Now, of course, the word of caution that some of the things you can do in Azure Machine Learning Studio, it's not the same as what you can do like in R or Python, and also vice versa. There's things you can do in R or Python that you cannot do in Azure Machine Learning Studio. At least not with the drag and drop. There are, of course, modules that allow you to embed custom R or custom Python code into the Azure Machine Learning Studio platform if you want to, but just something to keep in mind when you're thinking about and planning using this technology. I actually borrowed this from Matt Winkler at Ignite, but I thought this was a really great way to kind of think about the different options, when to use what. I showed you the visualing tool here. So this was the Azure Machine Learning Studio cloud platform and how you can integrate those results into Power BI with R. But if you're thinking about getting into this space, you have different options. So if you say, oh, I want to build something myself, or if I want to use something that was pre-trained, there's lots of great options within cognitive services that allow you to integrate advanced analytic capabilities into whatever application that you want without having to worry about coding something up in C++ or R or Python. But sometimes you say, oh, I do want to build it myself. Well, you do have the option of doing more of a drag, drop, and configure, which is what I showed you today. Or if you say, you know what, I don't want to do the drag, drop, and configure. I have experts in data science and in the appropriate languages. I want to code something up. You can do that again, like on service or on premise with SQL Server or Hadoop, or you can leverage the new cloud service. It's still in preview. It only supports Python right now, but it does allow you to have full flexibility so that if you want to use, for example, TensorFlow or Cafe framework, you can use those and still leverage the performance of the cloud and the ability to manage models in the cloud without having to kind of sacrifice on, doing code and picking your own framework or toolkit for that. So just to kind of reiterate, so again, everything that I mentioned, I tweet. I'm on LinkedIn. Look me up. The tutorial that you saw, or the webinar that you saw today, I covered in 2 articles. So you can follow that yourself and do it yourself. And I highly encourage you to do, because it's free. And that pretty much wraps it up for questions.
So we have a couple of questions. Let's go one by one. So first question is how much it cost? Any details about the cost?
Yeah, so if you're paying for the service, then there is a cost per seat. So every person that you want to use the Azure Machine Learning Workspace, I believe the cost is $12 US per month, but don't quote me on that. There is a pricing website that you can look up, and then so that's just to kind of have a seat within the workspace. But then there's also a cost with actually running experiments and using it, and it's kind of like resource based. That being said, we've used it several times now, and I find that the costs are it's very cost effective. On
Awesome.
average, if I had to guess, you probably end up spending around, between $500 and $1,000 a month, depending on how much data and how many experiments you're running.
Oh, I know you answered this, but just wanted to get one more time confirmation. Like, can we use Python in Power BI and SQL Server?
No, so Python cannot be run in Power BI, and that's actually the reason why I chose. So, the data sources that are available in Power BI are limited. So I mean, there are lots and lots of different data sources, but there is no Python, but there is one here, R script, right? And so that's
Okay.
why it's logical to go and use that sample R script code that the service or platform generates for you and tweak it, and then dump it into Power BI.
And can we use Python in SQL Server? Looks like he's a Python fan. So,
Yeah, with 2017 you can use Python.
oh, okay. So if we
But
have a SQL Server 2017, we can use the Python language there and still fetch the records in Power BI using that flow.
yeah, so if you want to use Python, I would recommend that you integrate your Python code kind of similar to what was done, what I suggested here, right? So in this scenario, instead of R code, it would be Python, and your Power BI would be hooked up to a stored procedure, and that stored procedure would run the Python code, and the Python code would score your data. But and actually the Python code can also call the API too, right? But again, the code that the platform generates for you, which makes it easy, is in C# or So I'll just show you again for the bottom here. So this is the sample code that the platform generates. It's C#, Python, or R. So yeah, you could just, if you say, you know what, I'm familiar with Python, I want to use that, you can go and grab this code. You can have that integrated into SQL Server, and then you just create a little transact SQL procedure to go and execute that Python code and hook it up to Power BI.
Awesome. So one person asked, can you post the decks? So the answer is yes. Once we will have a recording ready, we will publish that to YouTube, and we'll also publish the link for slides. So Anthony, we have few more questions, but I will definitely send those questions to you, and then we will publish those on our website. And definitely, Anthony, this was really a good session, and we really had a good overview as well as the code demo related to Azure machine learning and Power BI.
Yeah, it's an exciting time, and I highly encourage everyone listening to try it out. Right, especially with these platforms, they make it easy, and you can learn a lot and start to get kind of familiar with how the process works, what the terms are. Right.
Sure. So, all right, we will close our session, and thank you everyone for attending. Thank you, Anthony, once again for awesome demo.
Excellent. Thank you.